welcome everyone to the October Novice meeting. For those of you that don't know me, my name is Chris Morisette, and I'm the Novice Chair for the Houston Astronomical Society. And so we're going to embark on one of our quarterly sky tours, and this one's aptly named Navigating the Autumn Sky. And I love this time of year for several reasons. Um, we should be getting cooler weather. We should be getting hopefully clearer skies. And of course, you got football. So what's not to like about the autumn? Tonight, what we'll do is just do a quick refresher on navigating the night sky. And then we'll talk about the various signposts that you can use to find your way around the autumn sky. And then we'll do a sky tour of targets that are out there that are interesting to talk about and learn about and interesting to go see. Um, so we'll talk about that. And then at the end, I have a few announcements that I'd like to make. And again, if you have questions, just come off of mute and go ahead and ask. So, navigating the night sky. Um, this is one of my favorites, and I encourage you all to download these and use them each month. This is the map you can get free from skymaps.com, and they're really handy because you're able to take this map for free, go out into your yard or on the driveway, and depending on which direction you're pointing, south or north, you'll have the direction that you're physically pointing on the map. It will be pointing down towards the ground. So if I'm facing south out on my driveway, then I would have this map in the configuration that you see here on your on this slide. And the great thing about this map is it's got all of the main constellations and even some of the main objects that we'll be talking about tonight are located here. As well, you have the ecliptic, and Saturn is currently up. It just went into opposition last month, so it's still a prominent object up there in the night sky. And anyway, wonderful resource here. And I highly encourage y'all to use that. And then if you are out on your driveway and you say, well, gee, what's in the north sky? Well, you do a 180-degree turn, face north, and then you take that map and you turn it upside down so that north is pointing down. And then here again, you can see what the predominant objects are, constellations are in the northern sky. So Polaris at 30 degrees above the horizon is prominent. We will have over here Cassiopeia, which we'll talk about and when we get into our signpost discussion. And then the summer triangle, which is still useful for us even at this stage of our orbit around the sun. So, great resource. It's free of charge. Highly suggest using that. Obviously, everybody's using phone apps as well. Those are great too. I have my favorites as well, and you're certainly free to use those. But this is just something that for those that are just brand new, fresh to astronomy, this is a great way to start out. Again, our model that we use in order to find our way around the night sky is the celestial sphere. And all this is just an imaginary sphere that's around the Earth. The celestial poles mirror those of the Earth's north and south pole. The celestial equator mirrors that of Earth's equator. And then we have two parameters called right ascension and declination that define the point that you will find a star, that you will find a nebula, you will find a galaxy at. And those coordinates correspond to longitude in the case of right ascension and latitude in the case of declination. So for terrestrial coordinates, we use longitude and latitude. For celestial coordinates, we use right ascension and declination. We also have this other imaginary circle that is tilted at about 23 degrees on the celestial sphere, and this is the ecliptic. And ecliptics is where we're going to find the sun and the planets. And again, for viewing Saturn, which I highly recommend, I had a group out at Insperity. I teach a introduction to astronomy class at Lone Star College, and I had a field trip with my class out to Insperity, and it's very light polluted, but you can get wonderful views of the planets. And we looked at Saturn edge on, and it was a real crowd pleaser. And if you haven't seen it yet, make plans to see that while it's still high up in the sky, because it's a wonderful object to behold. Anyway, the ecliptic is where you're going to find Saturn. Okay. Here is another view of the celestial sphere, and imposed on this is the galactic equator. So we have the celestial equator in blue, this blue disk. We have the ecliptic plane in red, and then in yellow we have the galactic equator. And the galactic equator is simply the location in our sky of the galactic disk of the Milky Way. The galactic has all the dust and stars and material that make up the disk of the Milky Way. And that's at a 63-degree angle from the celestial equator. This is probably one of my favorite perspectives of the celestial sphere. This is actually kind of the inverse. If you took the celestial sphere, which is really Earth-centric, and you turn it on its head and make everything Milky Way centric, this is kind of what's happening out here. So here is our Earth right here, and it is rotating or orbiting around the sun on this path right here. And here you see the various points during the season. So here's springtime, and here is summertime. And then summertime, during summertime, we get these wonderful views of the center of the Milky Way. And that's because at night we're actually looking back towards the center of the Milky Way. We're currently down here in the fall period of time, and we are now looking out, kind of out into the depths of the cosmos. Um, we still have to look through the galactic uh, disk, um, but it's at its thinnest. So we're able to get better views out into outer space. And there are a couple of really neat objects that take advantage of this, which we'll talk about here shortly. But this is a great way to think about things. When we get into wintertime, we'll be looking out at the edge, outer bounds of the Milky Way, and then uh, we won't have as strong a view of the galactic disk, but we can still see it. Okay, so that is just a different perspective of our celestial sphere. I always like to show this one. Obviously, if you have an app on your phone, it's not as imperative to be able to use this, but as you get more experience and you want to try things totally visually, totally manually, you can use these finger measurements to tell the distance between two objects in the night sky. So with the pinky extended at arm's length, the width of my pinky is 1 degree. Three fingers at arm's length is 5 degrees. Fist is 10 degrees. Hook'em horns is 15 degrees. And then the Hawaiian hang loose sign is 25 degrees. So you can use these hand signs again as a way to measure distances between objects. It's a great way to learn and to see if you can measure distances. And I wanted to include that because I think it's important that we have a lot of technology and a lot of tools, and I think that's wonderful. But it really drives home your understanding if you're able to go out here and do things manually. Okay, so just a tool for you to practice with. Now, with that, we're going to talk about autumn signposts. And if you've listened to any of my seasonal talks, you know that I'm kind of a big fan of signposts. So the Milky Way, or not the Milky Way, the Big Dipper is one of the key signposts that we have that we can really take advantage of in the spring and the summer. And as you see in these top two quadrants of this drawing, we can do that because it's high up in the sky. Um, as we get into autumn and winter, the Big Dipper is down near the horizon, so it's not as useful a signpost as it was in the summer and the spring. As a matter of fact, it really isn't that useful at all. But I did want to kind of show that because it is a prominent signpost, and I wanted to talk about, the reasons why it is a good one in spring and summer and not so good the rest of the year. So for our period of time in the autumn, we are going to be relying on a couple of different signposts. So here is a map of the celestial sphere that is laid out in rectangular form, kind of like a wall map of Earth that you may have had in your room when you were a kid. And you'll see here that the area of interest for this autumn I've got in these green boxes. So on the left-hand side is kind of where we are early in the season. Um, let me back up here. On the left-hand box is kind of where we would start our discussion here of signposts, and then the box on the right-hand side is where we'll move to. And I'm doing that because, as you can see, when we get into winter, when Orion is the prominent signpost, that box is going to kind of shift to the left. So this green box is kind of moving left, and at this point in time, it's kind of run off the map and come back on the other side. Okay, so what signposts can we use in the autumn time frame? Well, the summer triangle is still a very useful signpost. And not only is it a useful signpost, but it has some really cool objects in it, which we'll talk about. We can still take advantage of the teapot, at least in the month of October. But as we get into November and December, the teapot is going to become less and less useful to us because by the time it's dark, it's going to be down below the horizon. But we can still take advantage of it in the early months of autumn. Over on the right-hand side is our signpost of Cassiopeia. And Cassiopeia looks like a W as it is rising. Well, take that back. It at certain points, if it's when it's rising, it looks either like an M or a W. I think and I can't remember, so forgive me. I'm having a senior moment. And then when it gets up to its highest point and begins to rotate back down towards the horizon, it looks like an M or a W, depending on what it looked like when it was rising. So the reason that the summer triangle and Cassiopeia, we use these as signposts is because they're very easy to find, or they're relatively easy to find. Um, the summer triangle is going to be basically right overhead, and if you're in a light polluted area, it's very easy to make out the stars Deneb, Vega, and Altair, which I neglected to talk about. Here, here, and here. These three stars make up the summer triangle. They're easy to make out, they're easy to see, and that's why we like to use these as signposts. And the same is true of Cassiopeia. So that's why they qualify as signposts. The teapot is another prominent signpost, although my experience has been you really have to be in an area where you can see above a tree line or you don't have any trees to contend with because it's relatively low on the horizon. At the dark site, it's very easy to see, very easy to use. And so that's a great thing about our dark side is you got a lot of horizon to play with. Okay, so those are our signposts. And now with that, we'll talk about our autumn sky objects. And so one thing I want to talk, just as kind of a prefacing comment here, um, I'm going to go through various objects that are of interest. A lot of these are difficult to find and see because they are not very bright and they're at great distances. They're relatively small. So I like to show them anyway because if you go to an outreach event or if you're with somebody else that has a large telescope, and you're at a dark site, for example, then you can make these objects out. Um, and so there's that angle, and then they're interesting objects just from an astronomical perspective. So I want to go through these, but if you're just really starting out in astronomy, there is no shame in making putting on your target list the Summer Triangle and Cassiopeia. Um, don't assume that those are going to be automatic for you or easy, especially if you're just starting out. But put those on your list and see if you can find those, and then that will be a great way to kind of wade into this exercise of finding objects in the night sky. Visual astronomy is it looks easier than it is. So, that's just a kind of a word to the wise here to say, hey, set the bar appropriately for you so you can get some wins early. Okay, so just wanted to make that comment. Um, Here is the summer triangle. And again, the summer triangle consists of a triangle uh, that is made up of the star Deneb, which is in the constellation of Cygnus, um, Altair, which is in Aquila, and Vega, which is in Lyra. And if you just draw a line between these stars here, you get the summer triangle. Um, and in and around Cygnus, you have some wonderful objects here that are really cool. So the North American Nebula, the Veil Nebula, and the Crescent Nebula. Those are really cool objects, and we're gonna go through and look at those. There's a nice planetary nebula in Lyra called the Ring Nebula, but we covered that in the summer talk. So we're just going to kind of focus on the left-hand side of the summer triangle for our autumn talk here. Okay, so the first one I wanted to talk about was the Veil Nebula. It's really a beautiful nebula. It is actually a supernova remnant. And you can see here the overall, they call this object that you see here the Cygnus Loop or the Veil Nebula, but it's actually composed of a couple of different parts, couple of different well-known parts. So, for example, here is the Western Veil Nebula right up here, and then down here is the Eastern Veil Nebula down here. So this object's about 2,600 light years away in the constellation of Cygnus. It's about 12 degrees below Deneb. So if you can find Deneb, which is one corner of the Summer Triangle, you're pretty darn close to finding the Veil Nebula. Um, Here, I believe I've got a close-up of the Eastern Veil Nebula. And before I go to that, let's talk a little bit about this. So this type of nebula, this supernova remnant, is fundamentally different than an emission nebula. Like in Orion, where you have an emission nebula, you're having starlight that is actually ionizing hydrogen and emitting the beautiful light from that nebula. Here we don't have that. Instead, you have this shock wave from that supernova explosion, which formed either a black hole or a neutron star. And that shock wave is actually energizing the interstellar medium around the location of that explosion, and it's that energy that is causing uh, s- the, uh, the interstellar medium to glow. So that's the cool thing about this. Its energy source, rather than being from a star, is actually from that explosion, which I think is pretty neat. Um, the one thing that you can really make out here in the close-up of the Eastern Veil Nebula is the colors and the coloration and the shape from this appears kind of twisted and all turned up. It looks to me, it almost kind of reminds me of a lightning bolt, and you can kind of pick that up from looking at this picture here. It's not like a fuzzy cloud that's glowing. It's more like a electrical bolt of electricity. And again, it's getting that glow and that shape from the energy from the shock wave of the explosion. So that's the Eastern Veil Nebula, which is one side of that of the Cygnus Loop or the Veil Nebula. So very cool object, and it's a faint object. You do need to have some relatively large diameter telescopes to see this, but I think it is doable. The next object that we're going to talk about here is the Crescent Nebula. And the Crescent Nebula is right at a star called Sadar. And let's go back and look at the map here. So it's right in this middle star, right here in the Cygnus constellation. And that is where you're going to find the Crescent Nebula. And this is really kind of a cool looking nebula here. It's a relatively small nebula. It's 32 light years in size, but it's about 5,400 light years away. It is an emission nebula. It was discovered by William Herschel, and it was formed by the fast stellar wind from a Wolf-Rayet star that is, I think, this middle star here in the middle of the nebula. And what you see here is kind of the result of a collision between two shock waves. You've got this bluish shock wave here, and then inside you've got the reddish material here. To me, it kind of looks like a human brain with all the creases and whatnot here in the middle. But this is an emission nebula, and it is being ionized by radiation from stars in the nebula itself. And forgive me for looking away, but I've got my notes here, and that's the only way I can kind of keep things straight. So forgive me for that. Anyway, the Crescent Nebula, definitely a challenging object to find, but one that would be well worth the effort. The next object we're going to look for is we're going to look at is the North American Nebula, and it is right next door to Deneb. I mean, I think it's within a degree of Deneb. So if you can find Deneb, you can find the North American Nebula. Now, this is a wide field of view shot, and you can make out the North American Nebula right here. And it got its name because of the shape. It looks like the continent of North America. And then right next door is another one called the Pelican Nebula. So that's a wide field of view shot. And here is a more close-up picture of the North American Nebula. This one is a very wide field of view object. It has, I think, it covers a region more than 10 times the area of a full moon. So a full moon is a half a degree, so that'd be about 5 degrees in size. It's a very faint object, though. It has a low surface brightness. So it's not the easiest object to pick up unless you have a large telescope and some filters, or you're doing EAA. Is another way to see it. Um, this object here again gets its name because of its shape. Here you've got the Gulf of Mexico or America, whatever your preference is there. Down along here is kind of the Pacific coast of Mexico and Central America. And you'll notice here this object that kind of looks like a bit of a wall. It's called the Cygnus Wall, I believe. Yes. And it is a region of star formation, which you see right in here. And that's a pretty cool object in and of itself. But that is the North American Nebula. And I'm guessing, which I shouldn't do, but if I had to guess, I'd say that was Deneb right there, because it is, like I said, it's just right next door to this thing. So these are three really cool, really interesting nebula that are right there in the Summer Triangle that you really don't have to do much navigation to. So that's a neat thing here. So those are three objects in the Summer Triangle. So with that, we'll move on. And the next object that we're going to take a look at is the Helix Nebula, which is right over here. So So here is where we're going to have to rely on our ability to get to the teapot, although we can still find our way there just by measuring from, say, Altair over. But if you still can spot the teapot, what you can do is you can go from Deneb to Altair down to the teapot. And then once you've found the teapot, you can go from one of the corner stars in the body and the spout of the teapot, and you can go 40 degrees over to the left. And by doing so, you'll find the Helix Nebula, which is in the constellation of Aquarius. Another way to do that is, again, to go to Altair and probably go about 35 to 40 degrees um, down and to the left. And that would be another way for you to get to the Helix Nebula. In order to find the Helix Nebula, you're probably going to need to do a little bit more research, look at finding the constellation of Aquarius and then honing your view in or honing your sights in to find the Helix Nebula in Aquarius. Here again, if you have an app on your phone, and I use one called Sky Guide, you can actually type in and say, put an arrow on the Helix Nebula for me, and then you can take your or your app up to the sky, and it will point you there until you've hit the object. So that's another way to do that, and that probably is a good way to find this one because, again, it is not the easiest one in the world to find. Okay, so what the heck is the Helix Nebula? Well, it's a planetary nebula. It's about 790 light years away from Earth, so it's relatively close by and it's very small. It has a size of about 3.5 light years. So it's a really small object. You're going to need a telescope that would be in the neighborhood of, 10 inches or greater in order to have an attempt at finding this. But you can find them. And this is actually bigger than the Ring Nebula. And I've seen the Ring Nebula through one of the large Dobs out at the dark side. So I know you can see these things. This particular object is not going to be colorful like you see in this picture. It's going to look more grayish just because our eyes really can't pick up the coloration like the cameras can for us. But you can still make out the shape and the faintness of the rings around the white dwarf in here, and they're really cool to see. Either EAA, but more if you can do it visually, those are really cool to see. So again, this is a planetary nebula, and planetary nebulas are what happens when stars the size of our own sun come to the end of their life. They run out of fuel, gravity takes over as the primary force, collapses the star into what's called a white dwarf. Doesn't have enough mass or energy to go all the way and form a neutron star or a black hole. It gets down to a certain point and then stops. And then you have this, what I like to refer to as kind of a campfire ember. It's no longer burning, but it's still hot and it's still glowing. And that radiation is what you see lighting up the remnant of that star, which is here. This is kind of the outer layers of the star that were shed, upon its demise. And so that's where the glow is coming from. And they are cool, and they are come in all kinds of shapes and sizes. So no two are alike. But this is the Helix Nebula. And the one thing about the Helix Nebula that's nice, it's one of the larger planetary nebulas that are out there. Okay, excuse me just a second. I'm going to grab a sip. Thank you. All right, so let's move on now. Now we're getting into the objects that I just totally dig, and that's the three sets of galaxies that we're going to be talking about here. So, um, We're going to first go to a set of galaxies called Stephan's Quintet. And Stefan, so we're going to utilize our signpost over here called Cassiopeia. And so that's where you find Cassiopeia. Now, getting to Stefan's Quintet is not going to be an easy chore because first you've got to find the constellation of Andromeda, and from there you've got to kind of trace your way over through Pegasus over to this upper leg of Pegasus. Okay, so it's not the most straightforward thing to do. And again, if you're just starting out, um, an app on your phone might be um, uh, a backup way to do this. I would certainly give that a shot as you're getting out there and looking, but if it just gets too frustrating, revert to the app and then go look for this object called Stephan's Quintet. And you can do that um, by either finding Cassiopeia and making your way out here, or a more fail-safe way would be to come down here into Andromeda, find the Great Square, and then make your way up here. And so once you do find Stephan's Quintet, which again, you're going to need some optics here to get to this and see it because it is a very distant and very faint set of objects here. As a matter of fact, this quintet of galaxies that you see here are about 320 million light years away. At least the most distant ones are. There's a galaxy here that's actually in the foreground. And then, so the five galaxies in question here in Stephan's quintet are this spiral one that's here in the foreground, this galaxy here, this galaxy here, which is kind of it looks like the collision of two galaxies, this galaxy right here, and then this galaxy right here. So those five galaxies make up Stephan's quintet. Um, the brightest of the grouping, again, is NGC 7320, which you see down here. And you can even make out some hydrogen 2 regions. Uh, there's some there's some blobs that are down in this area of the galaxy that you can actually make out. So those are pretty cool to see. Again, these are small, these are faint. You're going to need some pretty heavy duty, large diameter telescope, maybe even EAA in order to find your way over there. But you can see those. If you go to an outreach event, this might be a good means by which to go look for Stephan's or to go see Stephan's quintet. So but it is very interesting, very cool galaxy. I think set of galaxies, and I think this one right here is actually the antenna galaxy. Now that I'm thinking about it, um, but very, very interesting. And this is how we can take advantage of our position relative to the galactic disk, and where we can look out into the night sky. All right.
Hello, sorry, I wanted to ask, are those galaxies in the Stefan Quintet close to each other, or do they just appear close to each other?
I think they just appear close to each other. Let me check my notes here. I don't know if they're gravitationally bound. The four in the background may have some gravitational attraction to each other, but I know that the one here in the foreground is much closer to us than the other four. So but to be honest with you, um, a I don't have a solid answer for you on, how close they are relative to each other. I think the three here are at about the same distance, so I think they would have some attraction to each other, but this one definitely would not. Okay, that answer your question?
Yes, thank you so much.
All right, thank you. All right. All right, so now what we're going to do is move on to Andromeda. So before I get to the pretty picture, let's go back up here. Now, like I said, visual astronomy is not as easy as it looks. However, I personally have found the Andromeda Galaxy with binoculars in my front yard. So it can be done. What you're going to see is you're going to see a kind of a glowing, fuzzy core of light, and then you're going to see an oval of light of lighter intense of less intensity, an oval of light around that brighter core. And so, and I found this the old-fashioned way, which I'm proud to say, by going out here and finding Cassiopeia, finding this star right here, which is called Shadar. You can kind of make it out because it sort of sticks out in the W or the M, depending on what the orientation of Cassiopeia is. So you can kind of make this thing out fairly easy. And then what you do here is you make your way down to this arm here that is part of the Andromeda Galaxy. Okay. And then once you find this star right here, you can make your way up just a little bit and you can find it right in here. And it's really exciting to do that. Um, and not only is it relatively easy to find because I found it, but it's such a cool object. Not only is it cool looking, but it has a really neat history. So if I can do it, you can do it. And I just get a kick out of it. I'll just go out there. I may even go out there tonight and just test my ability to do it. I've also seen it out at the dark side, and I've seen it naked eye with binoculars, which I believe is the best instrument to use because it's such a wide field of view object. You can really see it in all its glory. And I've seen it through a larger telescope, which really allows you to kind of hone in on the central core of the galaxy. But it's very cool. Okay, so here is a picture of M31, which is the large spiral galaxy, and its two companions galaxies, which is M32 and M110. And those three galaxies are gravitationally bound to each other. Um, this is Andromeda is about 2.5 million light years away from Earth, so it's not as far as as Stephan's quintet, but it's still pretty far out there. And it is the largest spiral galaxy closest to the Milky Way. It's about 130 light years in size, the disk here from here to here. And which makes it about 30% larger in size than our own Milky Way. Okay. Um, there has been some computer modeling that has been done regarding M32. It's believed that that galaxy actually did collide or move through or around or close to the disk of Andromeda and actually warped and kind of deformed it to some degree. So that's a pretty cool fact about Andromeda as well. The coolest thing about this object, in addition to its beauty, is the history behind it. So Andromeda was long thought to be a spiral nebula located in the Milky Way. And during the early 20th century, there was a lot of debate going on about, you know, is it really part of the Milky Way or is it something entirely different? So enter Edwin Hubble, who did a lot of observations of Andromeda. He determined using Cepheid variables, stars, that the distance of Andromeda from the Milky Way was much farther than we had ever thought. I think he originally estimated it to be somewhere around 900,000 to 1 million light years away. And that clearly put it outside the bounds of the Milky Way. And this was confirmed with later measurements. And I think the significant part about that whole story is that by determining Andromeda and its distance away from the Milky Way, it really opened up our view of a broader universe. before the Milky Way was our universe. Now, all of a sudden, we are way out farther and beyond our Milky Way in witnessing something much bigger on something on a much larger, grander scale. So that was a significant discovery. And I think that, along with Einstein's theory of relativity, really set the stage for research from the early part of the 20th century up till today. So that's a really significant piece. Um, just before I leave this picture, you've got you can see the dust lanes in this picture really clearly. You can even make out some nebula that is actually in the Andromeda galaxy that we can see. I don't know if I've got that labeled here. I don't think I do, but it's really neat to look at, and I just get a kick out of it every time I look at it and talk about it. So you get this nice glowing core here, and anyway, I could wax nostalgic all night. Okay, so that is Andromeda. Again, a great target and one that you can find. And then our next target here will be Triangulum, which is another galaxy. And you're going to find this about 10 degrees southwest of Andromeda. So if you can find the Andromeda galaxy, you're going to want to go 10 degrees that away over kind of on the other side of these arms. And then you're going to find M33. And here's a beautiful picture that Jeff Lepp took of M33. Now, I'll be honest with you, I've got this on a astronomical list um, uh, challenge that I'm doing uh, for binocular viewing. And it's the rumor is you can find this with binoculars. Now, I've looked in my front yard and it's just there's just too much light. I've tried looking out at the dark site, but I don't think I had the right conditions. The last time I was out there was we were fighting clouds all night. So um, the next time I am out there, hopefully this fall, I'm going to give it another shot, but I have yet to find it with binoculars, but um, I'm not going to give up. And anyway, this is Triangulum. It is another spiral galaxy in our local group. So Andromeda, Triangulum, and the Milky Way are three large galaxies in our own local group. There are a number of dwarf galaxies as well that reside in the local group, but these are the three big galaxies. Triangulum is about 2.8 million light years away, so it's a little bit farther away than Andromeda, and it is a spiral galaxy. It's about 51,000 light years in size, so it's about half the size of our own Milky Way, but still pretty significant. Um, Herschel cataloged Triangulum Galaxy's brightest and largest H2 region, and I think he eventually named that NGC 604. And if I'm not mistaken, I think it's right in here. This bright region that you see right here is NGC 604. And again, it's a hydrogen 2 region that does actually reside in Triangulum. And let me see what else I've got on this one. Yeah. So that's Triangulum. And again, it's another great target. You'd probably be best served by using, a Dobbs telescope of, a minimum of 6-inch diameter, preferably bigger. And don't know if you'll need any filters or not, but if you're out, like I said, out at the dark side or a dark location, you've got a pretty good shot at seeing this. And they tell me it can be found with binoculars. So that's Triangulum. And then next, we're going to go and wrap up our talk here with the Heart Nebula, which is right in the vicinity of Cassiopeia. And so I took this screenshot out of Sky Safari, and this is what you'll be looking at tonight at 9 o'clock in the night sky. And I think this is going to be Cassiopeia coming up. So Cassiopeia would actually um, have the W shape, and then I think on its way down, it's going to have the M shape. But rather than belabor that point, I'm just going to say that it's a W at one point and an M at another. So if you go off this trailing star here, so remember we use this star right here to get down to, or this star right here rather, to get down to Andromeda. Here we want to make our way back up the constellation, then on off the tail end you'll find the Heart Nebula. Okay. Now the Heart Nebula is going to be a difficult one to find. It is an emission nebula, but again, it's going to have a really low surface brightness. The Heart Nebula is about 6,200 light years away and 107 light years in size. So it's a relatively large field of view object. You might have some luck if you focus in on finding this star cluster right here. Unfortunately, I don't have that name in my notes here, but this star cluster at the center might be your best means of tracking this thing down to begin with. A couple of things about this nebula. It is an emission nebula, like I mentioned early. There's a lot of radiation coming off of stars here that is making these clouds of gas out here glow. And then there's also been enough radiation emitted to actually hollow out this section of the Heart Nebula and this section of the Heart Nebula as well. So, kind of reminiscent of the Rosette Nebula, where you have some powerful stars in the middle with such intense solar winds that it's actually blowing this gas away. And that's what you're seeing here with this shape. Again, it's a great object um, to go after, and it is really beautiful and relatively easy to find, at least when looking up at the night sky. Once you've gotten to well, I say find, I mean actually kind of finding its location in the night sky. So that's our Heart Nebula. And so here is a table that I put together for you to, just kind of as a guide. Here you can get an understanding of what kind of equipment you would need in order to find these types of objects. Um, People have asked me, well, what's a small telescope and what's a large telescope? I tried to put some of that up in the notes here. So I call a small telescope something that would be like a refractor that's say greater or as 4 inches or less in diameter, and then a large telescope being something greater than 5 inches, and that would typically be something like a Dobbs. Um, EAA can be applied in to even some small telescopes. So I have a 2-inch refractor that I've used a camera with, and I've been able to find the Heart, Andromeda, um, the North American Nebula, the Eastern Veil Nebula. You can do a lot with EAA. But if you don't have that kind of equipment, again, going to an outreach event or going to public night viewing at a place like the George Observatory, there you can get access. A lot of people are using the sea stars now, and the sea stars are able to pick up these faint objects as well. So, that's another great tool. But again, you can use binoculars and Andromeda. I mean, try for Andromeda because that I guarantee all kinds of excitement with that one. Um, Another thing too, I mentioned earlier, setting your the bar low to kind of get some quick wins. The summer triangle is a good one. Once you've found the summer triangle, finding the constellation Cygnus the Swan, that's another good one. So, put that on your list as well. As a matter of, and I'll just share with you some stuff that's coming down the pike. We are going to, starting next year, I'm going to begin to put those simple kind of backyard objects on the list as well, so that you can go out and find these and um, actually get some credits for uh, some prizes or gifts. But I've got to work some things out with the incoming membership chairman, so that's all kind of up in the air right now. But at a minimum, I'll put them on the list starting next year. I got this from Goldberg a while ago, and I thought this was kind of neat. It's just another way to look at our objects that you can go out and look for. I've got M31 and M33 circled, but this kind of gives you another view of, um, you know, uh, objects when you can find them in the autumn, spring, fall, whatever, and how easy they are or hard they are to find. So anyway, I thought it was kind of fun. And we've got there's a lot of good events coming up this month that are, solar system or, celestial events that are more solar system centric. And so let's just talk a little bit about these. For example, Saturn, I mentioned earlier, is still up in the sky and it's still one to go out and find. Binoculars, you can see it with binoculars, small telescope for sure. So that's on there. This Saturday is the International Observe the Moon Night. So I know there's going to be a number of outreach events around town where you can go and look and observe the moon. Um, I think I saw a note from Dan Roy about some things that are coming up. If you live up in the northern part of the county where I'm at, Insperity Observatory is having a moon observation session Saturday night. So that's there. There are a number of comets that are up, which are really exciting. So you have on the 8th, and these numbers are the date in October. There's a comet here, K1 Atlas, that is getting close. On the 14th, the moon is going to be near Jupiter. On the 19th, you've got the moon near Venus. And then on the 20th, we've got R2 Swan coming in with its closest approach to Earth. Um, if I have if I have a good vantage point for this one or the Comet A6, which is making a close approach to Earth, I'm going to get out my DSLR and see if I can get a shot of that. But this is the third comet. There's actually four comets that are occurring this month. So that's very unusual. So you have this R2 Swan, you have the A6 Lemon. There's a meteor shower that peaks on the 21st, and this is coming from debris from the comet Halley. So that's pretty interesting. So, and then this interstellar comet uh, 3I, it's either I or L Atlas. So a lot of great viewing out there this month. So there's a lot of action, a lot of activity coming up. So with that, I'll just encourage you to get out there and stargaze. Autumn's a great time. I hope this weather cools off. I don't know about you, but I'm really tired of this heat. So I'm looking for a good cold front to come through and blow this stuff out of here. All right, so let me wrap up with some announcements. First announcement I want to make, I'm going to try and get some Novice Labs teed up over the next 6 months. For those of you that have never been on a Novice Lab, what we do is we go out and put the principles that we've talked about in these seasonal meetings into practice. So I get out there with a laser pointer out at the dark site and we'll identify signposts together, and then once we've done that and kind of demonstrated how the celestial sphere works, we'll go out and find these objects. And so that's always a lot of fun. And we always get some people out there that, have some great experience. And even on a cloudy night, we still had fun here back in April. But we've got some cooler months coming up, hopefully clearer months coming up. And I want to try to set these up at the dark site, and I'm going to try and tee these up October through March, and I'll do several of these. So what I like to do is kind of break things up into small groups so that we can work together and I can manage the group, and we have people are there and we can help each other out. So um, the times I'll set up the times basis the feedback I get from people. So uh, I'll be sending out an email here probably at the end of October. I've got a couple of personal commitments I've got to take care of in the next 3 weeks. So once I get that done, I'll get a note out to everybody, and then you can just reply back to me with the information requested if you want to participate. But I think this is a great way to, put things into practice. And it's just great to be out underneath a beautiful night sky. Um, I'm also going to be soliciting the or developing and putting together the 2026 novice presentation schedule. Try to do this between now and the end of the year. So, and I'll send out an email to the group with all this information. But since I had you here, if you've got any topics that you'd like to hear about, let me know. And I've got 3 email addresses here at the bottom that you can reach me at. Um, I put these together kind of basis the topics that I think are neat and that I think people would want to hear about, but that doesn't necessarily mean that they're what you want to hear about. So if you got any topic ideas, send them to me. If you're interested in making a novice presentation, let me know. You don't necessarily have to build your own novice presentation. I'd be happy to have a guest speaker come in and deliver one of these quarterly presentations. That's how I got my start. I think they're uh, great ways, they're great things to do because you can achieve a number of things. Number one, if you want to practice your public speaking, this gives you great practice in doing that. Um, it's a really great way to learn. If you've got to put a presentation together for a group, um, there's nothing that motivates you more to learn about a topic than knowing you're going to be up in front of 20 people giving it. So that's really good. And it just helps you in your journey to learn more about astronomy. And then finally, it's just a really great way to contribute to the club. So um, I know public speaking isn't for everybody. So don't worry about that. I get that. But if you think you might be interested, let me know. I'd love to entertain you. And I hope we got a guest speaker next month, Will Sager. So that'll be nice. You'll be able to hear somebody else and not me put you to sleep. So anyway, just wanted to make those presentations. And then I also wanted to remind you that tomorrow night at the general meeting at 7 o'clock, the topic will be Our Amazing Star, which is about our sun. And that'll be given by Dr. Kevin Reardon. So I hope you all can join for that. And with that, we are finished with the presentation. And if anybody has any questions, I'll stop sharing here. If anybody has any questions, I invite you to come off of mute and ask your questions. And I'm going to go ahead and check out the chat here, see if
Hey
any.
Chris, can you hear me?
Yes, I can.
Good evening. This is Hadi. So I was wondering, earlier you mentioned looking at Andromeda tonight. I was aware that it was visible with the naked eye. Should have been last night, but I had too much light pollution. Will it still be the same if I try to go out tonight and still look for it?
What part of town do you live in?
Right now I'm in Denton, Texas.
Oh, you're in Denton. Oh, wow. Okay. Well, that's north of
Yeah.
Dallas. So, I don't,
Yep.
right where I'm at is like a Bortle 6 or 7, I think, here in Kingwood. You might check and see what your Bortle rating is, but
Hmm.
hey, give it a shot. I mean, again, it is surprisingly. I found it surprisingly easy to find. If you've got a lot of street lights, though, I know I've got a couple that I have to contend with, but I can kind of get behind a tree and look up, and I can see it. But I really need, in order to see it, I really need a moonless night, and I
Hmm.
need I need a cloudless night too. It's got to be really clear. So
Clear.
I guess my best
Yeah.
advice is just give it a shot. But I would try to wait
Okay.
for
Thank
a
you.
moonless night would help you out.
Great. Thanks so much.
You bet.
Yeah, I'm
Okay.
looking forward to Swan because in October 14th, it'll be like at 11 o'clock at night. It'll be kind of around not Libra. It'll be near the Milky Way. Did it on Stellarium. Yeah, like in Ophiuchus area.
Mm-hmm.
That's where the comet will be on October 14th at 10 o'clock. So it'll be visible low on the horizon.
Okay. How
Nice.
far above, how far up above the horizon is it anticipated to be?
Well, at 10 o'clock, it'll be right at kind of near the teapot actually.
Okay.
I kind of just did a broad screenshot, so I can't give you exact, but I got on Stellarium, I found the comet, and I used the date adjuster thing to kind
Right.
of like go forward in time and see how above the horizon it got so that I could start shooting it from my, my patio.
Right.
And it might be nice because they'll have a cool little bit of the core in the background. It's right
Yes.
next to the dark horse, so kind of right where Ophiuchus is.
Gotcha. Yeah, that's a good point, Heather. I tried last night to look for one of the comets, and it was still twilight.
Oh, lemon, yeah.
Yeah, it was so close to the horizon that, and it was too light that I wasn't able to
Yeah,
find it. So you got to get it, you got to look for it at a position that is, you know, enough after dark that it is dark and
right.
it's high enough up in the sky. So,
Yeah, so luckily that this one will be, right on the west, kind of in a good spot. So I think if you can find it on Stellarium and kind of track its, hopefully it won't burn up.
yes,
Fingers crossed we'll get another good one.
absolutely.
Because there's people posting photos of lemon and swan together, but that's the southern hemisphere right now, I think. So because one of them, lemon, I think you can't get them together here right now. So,
Okay. Yeah,
but
I pulled that list um, off of the sky maps.
mhm.
So just for, if you download that sky maps handout, you'll see the list plus some ones that
Yeah,
I just took off the list to kind of clean it up. You'll see that whole list there. So
definitely excited to give it a shot again, imaging them.
yes,
But
correct.
seeing that one last summer at the dark side for the first time, oh my gosh. It was like November of last year, I think, it was Atlas, I think. And it was my first time. I looked up and I was like, is that the Milky Way? And then I looked over and I was like, that's a comet.
Yeah. No, I
Dark
mean,
side is a magical place.
so for people that have never seen a comet before, I mean, so before I've been in the club since 2020, and I'd never seen a comet before. And then I saw that Neowise in I think
Mhm.
2020, and then I saw that Su Shin Shan, the Atlas
Yeah.
last year, and that was really cool. So they're great to go look at, and
Yeah, I missed Neowise and I tried to image Shushin Shin. I got kind of a green fuzzy ball, but seeing a naked eye comet for the first time was like an incredible thing. So if it's in the sky and you can get to the dark side, like I can't recommend it enough. Like I just looked up and it was right there. It was so cool.
yes, no, they're really neat. I'm looking through the chat. Carlos asked, do the Novice Labs require telescopes? So, no, they don't. Um, I will bring binoculars, and then I'm trying to get my hands on a used small refractor. But typically, people that sign up will have telescopes as well. So, either myself or somebody else will have equipment that we can utilize. So, if you don't have a telescope, that's not something that you need to bring. But if you do have one, by all means, bring it for sure.
And
What
Chris,
is, yeah,
I just had another question. Did you already send the October sky map? Did you
uh,
already share it with the HAS group email? Like the October sky map, the one you were showing in the presentation earlier?
yes. And what was the
It's
question?
just skymap.com.
Oh, okay. I was
Yeah,
asking because usually there's one that they send monthly through email. So I was wondering maybe I have not received it or not.
yeah. If you just type into Google search skymaps.com, all one word, it'll take you right to the site, and then there's a spot you can go find. It's called downloads, and you can just go there, and it'll you can click open and open up the PDF.
Oh,
So
okay. Cool,
yeah,
cool. Thank you.
you bet. Carlos asked, what is the name of the app that I recommend? And Heather offered Stellarium, which is a great app. I use one called Sky Guide. That I
That's a
found
good one,
was
yeah.
easy one to, to use as a beginner. And then Sky Safari is really a great one too. It's got a lot of information in it. So
And it helps that they all have that AR mode now. So like if it kind of helps you find it because you can turn on the AR mode and like see the tree that's in your
yeah,
yard. Yeah.
yes, yes. So a lot of great tools out there for sure. Okay. Are there any other questions? And I will be recording, I am recording this meeting, so a recording of the meeting will be posted on the YouTube channel for HAS, so you'll have access to this presentation.